Hello everybody, my name is Rotary Salvatore, and I did not think I'd be making a video today. However, I had to. I just had to for this particular subject. The last time I made a video relating to physics, it was related to the IQ of the girls from Madoka Magica, a Japanese television series, and that video wasn't so good. I'm fairly sure that most of the math on that was wrong. I'm also fairly sure that I did not speak Japanese correctly. However, this video is going to be better. I promise you, okay? Let's start off with a question. How much money do you think it would cost in order to completely vaporize a mug full of water, a glass mug of water? I came across this after a physics problem on one of my AP Physics 2 worksheets, and this is the problem. A 0.3 kilogram glass mug at room temperature contains 250 milliliters of water at 15 degrees Celsius. A 300 watt electric heater is used to heat the cup to boiling. How much thermal energy is required to get both the cup and its contents boiling? Now, I challenge you to try and solve this on your own if you are a physics enthusiast like I am, but we're gonna solve it here today. However, I interpreted the question a little bit differently than I think they wanted me to, and by that I mean I solved for how much thermal energy it would take to get the cup and the water boiling, which means that the glass would be boiling. So first let's solve it normally. We need our data. So from the problem we know that the mass of the glass is equal to 0.3 kilograms, the temperature of the glass is equal to 21 degrees Celsius, because Celsius is better, and the mass of the water is 0.25 kilograms because the density of water is 1 and the volume times the density is equal to the mass, and in this case the volume is 250 milliliters, and that mass that you get from the density equation is in grams, so we converted it to kilograms, and the temperature of the water is 15 degrees Celsius. We'll need just one equation for this problem, and that equation is Q equals mc delta T, or in other words, Q equals mc multiplied by the final temperature minus the initial temperature. Now, Q in this case is going to be measured in joules, or energy, the mass in kilograms. C is going to be your specific heat, which has some strange units that I don't really care to explain right now. And of course temperature is going to be in Celsius. It can also be in Kelvin though, it doesn't really matter. So you'll notice that we don't actually have C right now in our data, so we just have to pull that out of thin air, aka the internet. So the specific heat of water is 4,187 and the specific heat of glass is 792. So then we can just plug both of our substances into the equation and add them together, and we get the total amount of energy needed in order to bring the water to a boil. Just the water. So let's do that. So plugging it into our equation, we find that the answer ends up being 3.45 times 10 to the power of 4 joules. I forgot the J in there. Right, which for reference would take about 2 minutes for this 300 watt heater to heat up, right? So, let's take it a step further. How much energy would it take to boil the glass? In order to find that, all we have to do is replace our final temperature for the glass, because this is the section for the glass, and this is the section for the H2O, right? We just have to replace this 100 with the boiling temperature for glass, which is 2,230 degrees Celsius, which is a lot, and that changes our answer just a tad, just a little bit. So we end up getting 2.26 times 10 to the 6 joules, which, for reference, is 2 orders of magnitude higher than the last amount of energy we calculated for just boiling the water. And dividing this by 300 gets us the amount of time it would take for this heater to boil the glass, which ends up being just about 2 hours, as it turns out. Only 2 hours. So let's take it a step further. What if I wanted to completely vaporize the mug in the water? How long would that take, and how much energy would that take? Well, for that, we are going to need to add on to this. Right, with editing magic, it has moved. Now, what we need to do is add the amount of energy it would take in order to completely vaporize the glass and the water. So, in order to do that, we need the latent heat of vaporization for water and for glass. Now, we do have the number for water, which ends up being 22.6 times 10 to the 5 joules per kilogram, so that's energy per kilogram of mass. But for glass, it's a bit iffy, because glass doesn't necessarily vaporize consistently. It does vaporize, don't get me wrong, it just doesn't do it consistently. It's a gradual thing. So I just had ChatGPT take its best guess at it. I hope it's right, and ChatGPT gave me 1.05 times 10 to the 7 joules per kilogram, which seems reasonable, so we're going with that. Now, all we have to do is multiply out our masses, so we need to multiply out the mass of the water here to get rid of the kilograms, and the mass of the glass here to get rid of kilograms. We have our energy. So, let's do that. Now, if we add the amount of energy it would take to boil both the water and the glass to the amount of energy it would take to vaporize the glass to the amount of energy it would take to vaporize the water, we get around 5.98 times 10 to the 6 joules. Now let's finally answer the question that I asked at the start of this video. How much would it cost in order to completely vaporize a mug full of water? If you haven't guessed already, then make your guesses. Converting the joules to kilowatt hours, we end up getting around 31.08 cents in America. That is not a lot. Well, thank you for watching my video. My name is Rotary Salvatore. I expect this one will be far more accurate than the previous physics-oriented video, which I'm still considering just taking off of the internet because it was rather embarrassing, but at the same time it was too funny not to exist. Hope you enjoyed it. Hope you learned something.